Hello everybody and welcome to today's video. This one is all about sketching the derivative of a function if we already know something about the curve of f. Okay, so let's get some basic things out of the way straight away. So first, let's say if I have a function like this, just a straight line, y equals f of x, um, equals, I don't know. Let's say this is, I haven't marked my axes. Let's say this is 2x plus 3, for example. This is a straight line. The derivative here, as we know, hopefully, the derivative of 2x plus 3 is just going to be 2. Okay? And so if we plot the derivative of 2x plus 3, we're just going to get a horizontal line. That is because the slope of 2x plus 3, the steepness is the same everywhere. Any x value that you look, the slope is the same, so constant slope, so the derivative looks like this. So this is y prime equals 2. Very nice. Now, let's say if we go one more derivative, let's say if we take the derivative of this, we get the second derivative. And what is the slope of a horizontal line? The slope of a horizontal line, of course, is going to be 0. And just to be quick here, I'm going to put y equals 0 on the same axes, everybody. So here we are. Y double prime in purple here, y double prime equals 0. Okay, so, not too bad, right? So if we have any straight line, we can easily sketch the derivative, and its second derivative will always be 0. And, of course, we probably don't need to do this, but maybe we should. Let's say we have a line like this, right? Let's say this one is, can we pick something that makes sense? Let's say it's negative 1.7x plus, I don't know, 2. Okay. So, here the slope is negative, so if we plot that down here, if 2 is here, the negative 1.7 would be, somewhere here. And that's all there would be to that, and then both of them would have the second derivative. So in other words, y prime is negative 1.7. Sorry, decimal point goes here, and then the second derivative is going to be 0. So there we go. Okay, so some sort of introductory remarks about that. And before I destroy the rest of the screen, let me add a new layer. There we go. Okay, now for the more relevant part of today's discussion, which is sketching derivatives for curves that are not straight lines. Okay, so let's just look at this situation here. So just, something like this. Okay. Looks like a trig. And it basically is. Stop it here. Let's stop it here. Okay. Now, let's say this is the function f of x. And now, let's see, let's continue this down. What I'm going to do is on this second x-axis that I'm getting ready to put here, I'll keep the axis green and then I'll change the color. The axis here, we're going to put the first derivative right underneath f of x. So, all right. Here we go. Let's take note that we have f has a maximum here, f has a minimum here, and let's just say let's just say that this is a maximum as well. Okay. Um, and then we have this is going to be a local minimum. Okay, so we have these 5 important points. And now let's take note at what's happening to the slope. Okay, so as we go from here to here, we have a positive slope. Okay, positive slope, but it's tending towards 0. Okay, it's yeah, so it's positive, but it's approaching 0. That's what's happening here. And now here we have the maximum. So here, as we've discussed several times, the slope is exactly 0 here. And then over here, the slope continues to get negative. Okay, so this is negative slope, and not only that, it is getting more negative. Okay, I don't want to get the screen too jumbled up, so I'm not going to write it. But it's getting more negative. The steepness is increasing in the negative direction. Okay, now that is the case until we get about here. Okay, and this is just a nice. This is a nice Unit 5 discussion we're having here, everybody. Right here, about approximately. I'm just looking at the curve. Um, the slope stops getting more negative and starts to turn around the other way. Okay, in other words, my graph goes from concave down, my function goes from opening down, and right about here it starts to open up. I still have negative slope, but instead of it getting more negative, it's tending towards 0 here. Okay. Um, so yeah, so here we have negative slope, and it's tending towards 0. And then as we go this way, our function's still opening upwards. Okay, but here we have positive slope, and it's increasing. The slope is increasing. Okay, until once again, until we get about. I did not mean to put these on the axis. This was a happy, maybe not such a happy accident. I did not mean to put these on the axis, right? Um, it just happened to work out that way. But right here on the axis, we start to turn um, from getting more positive, and then we start to turn around again. The slope starts to approach negative. In other words, F starts to open downward again. Okay, so here in red, we have our inflection points. Okay, that's where we go from concave up to concave down, or vice versa, right? Concave down to concave up. That works as well. And let's remember, if we have an inflection point, our second derivative is going to be 0. Okay? So we are extracting information about the first derivative. We're also extracting information about the second derivative just by looking at the shape of f of x here. Okay? So now let us try to plot the first derivative. Okay. So once again, first derivative, we are looking at the slope of this graph. And if we're looking, the slope starts very positive and then it tends towards 0. Okay. So I'm going to come straight down here. This point on my derivative graph is going to be, and to emphasize this, I'm gonna do this. I'm gonna come straight down here. This point, and now I'm gonna get rid of that since I know where it's gonna be. Um, the derivative is gonna be 0. Okay. Changed my color. How bizarre is that? Derivative is gonna be 0 there. And once again, we're steepest here, and so this function will be most positive here. And then, okay, and then what happens after that? After that, the derivative starts to become negative, and then here, the derivative is most negative, and this is where the slope starts to turn around. So basically, again, didn't mean to put it on the axis there, but this will be where the slope is a minimum. It's where the slope is steepest in the negative direction before the slope starts to increase, starts to tend towards zero. And so what we wind up with here is a graph that looks kind of like this. There we go. Okay. Now let's keep going. Okay. So from here to the minimum, let's go ahead. Let's put that minimum in there, right? The slope at the minimum is going to be exactly zero. So let's drop this straight down. And we don't need that anymore. There we go. We have that. And let's double check. Is the slope increasing from negative to zero? It absolutely is. So we are going to smoothly connect these. There we go, just like that. And now what's happening? Now the slope is getting a little more positive, a little more positive, a little more positive until this point right here. It's maximum positive here. And so this will be, sort of where the maximum is for the slope. And I don't really have any information here to tell you, if it's more positive than here or not. Um, so oops. But anyway, now again, let's double check here. The slope is zero, and then the slope is increasing, increasing, increasing until here. And good, that's what we see here. So zero, and we're increasing, increasing, increasing until we get to here. And then after that, the slope is still positive, still positive, still positive until it's zero here again. So let's take that down there, straight down. Boom. There we go. Awesome. And now we connect these. And now there we go. So this is y prime, which is f prime, which can also be written dy dx. This is the graph of the derivative of the top one here. Okay. So yeah, very cool. I hope that makes sense. All right. And now if we want to plot the second derivative, which we are going to do literally right now. What would be the best way to do it? I guess I can't come over there. Okay, I guess we'll just go straight down again. So, not a problem. So, oops. We want to be able to, of course, determine the derivative of a graph from the original. But it's also good to be able to tell about the second derivative from the original. And that's what we've done here in red once again. Okay, so where these inflection points are, the second derivative is going to be exactly zero. So here is an inflection point. So we know immediately. Let me put my other axis here. Be good. We know immediately that at x equals 0 here, we know that my mouse is being weird. The second derivative is going to be exactly 0 here. And here's the other one, which again, that was an accident. We're just going to carry that down. So we'll carry that down straight from this maximum here. There we go, just like that. Okay. So we got those points just from looking at the original, just from knowing that these are inflection points, where the concavity of this function changes. But we can also get there just by looking at the slope of this one, right? Here the slope is exactly 0, 0. Here the slope is exactly 0 again, 0. There we go. Okay? It really is that simple. It's the derivative of the derivative. It's the slope of the slope. Okay? So we just need to look at the slope of this graph. So, same kind of reasoning here. Here the slope is, it's negative, but it's negative, but it's like shallow negative, right? And then here it's most negative. Here's where it starts to turn. It's where the concavity changes here. So anyway, yeah, the slope. So it's going to be let me come straight down. It's going to be shallow negative. Shallow negative, so something kind of like that. And then from here to here, we're going to get more negative. You can see the slope is getting steeper. Okay. There we go, kind of like that. And there we go. Slope getting more negative, more negative. Now the slope is getting more positive, getting there, and here's slope 0. Okay. And so what we wind up with is, not the prettiest in the world here, but we get the idea. Okay, so now slope is exactly 0 here. And then we're slowly positive. Here, again, we're most positive, and we start to turn around here. So this is where our slope is going to be a maximum. Oops. Slope will be a maximum here. That doesn't look too bad. Okay. Slope will be a maximum here, and now what's happening to the slope? It's steep positive, but it's starting to approach 0. Starting to approach 0, and then it's negative. So there we go. There we go. So yeah, so this one's a maximum. This graph is a maximum. The slope is 0. Slope is 0 here. Okay. And now as this graph approaches 0, the slope actually gets more negative. Okay, so we wind up with something like this. There we go, something like that. All right, so once again, this is the second derivative. Okay, and as you can see, just by knowing the I'm sorry, just by knowing the function itself, the original curve, we can determine not only the first derivative, but the second derivative as well. Okay. So there, and what we can do is we can sort of check ourselves and make sure that things are the way they should be. So here, for example, we can see visually that this function is concave down. It's opening down. Then we can see it starts to open up, concave up, and then it starts to open down again. So we can just see from here we should have negative second derivative or opening down. So let's check that. Negative second derivative. Our second derivative is below the x-axis here. Then we're concave up. Okay, until we get here. So we should see a positive second derivative from between these 2 points. Boom, boom, and that's exactly what we see. And then we start to open down again. Boom, just like that. Okay. So yeah. So we check ourselves with the first derivative by looking at the slope. Positive slope, zero slope. Negative slope, you know, more negative, less negative, more negative, less negative. Um, zero slope, zero slope. Positive slope, super positive slope. Less negative, back to zero. And then, yeah, anyway, we just did it. Okay, very nice. This has been pretty comprehensive. I hope this makes sense. I'm going to call this video. See you later.